Because if I tell you I'm working with a function, you know it could represent something in the real world. So I got a rocket. So an immediate usefulness of this is somebody I was going to say throws a rocket at, shoots a rocket at us. We have our little thing, what was it, the Patriot missiles, remember that, way back? You guys are probably 4 years old or something. So we want to shoot this up so that it actually intercepts this at the right place. So that's going to be a function that can only be at one height at a certain time. Mine's going to be a function, and I want to see where they're going to meet, right? So we've done that kind of thing before, actually. We solved two equations at once, systems of equations. So now if you merge that with this, you've got something you can use in real life to save these people over here. Thank you. Maybe. Of course, in real life, it's a little more difficult because then you have 3 dimensions in real life. This missile could be going, woohoo, you can't get me. Right? Won't be talking, probably. Talking missile wouldn't be much use. All right. So you got a visual, you got a straight up word definition. Let's make this even a little more technical. Oh shit. So if I give you a graph, that should be pretty straightforward to tell if it's a function or not. Is there anywhere you can draw a vertical line that goes through more than once? Is there anywhere it comes back on itself? Right? So that's straight up. What if I give it to you like this? Is this a function?
No. No.
So number one, let me ask you this. What are the inputs? What are all the inputs?
1, 4, 1, 7.
Anybody know a better name we call this instead of inputs? The collection of all inputs is known as the domain.
Axis.
So this is also called the domain. All the domain is a collection of all the inputs you can use. Sounds like a note. The domain is a collection of all the inputs that the function can use. What are all the outputs? 7, 9, -6, -6. So that's going to be, so you wouldn't risk -6 twice, right? You would say, what kind of, I think, blue. You already said blue, stop it. So this is also known as the range. The range is a collection of all the outputs. Now, if you think this is not a function, why do you think it's not a function?
No, -6 has nothing to do with it.
I love it. Because what are you looking for? For every input, there can be only one output. So, does 1 have more than one output? No. 1 only goes to 7. Does 4 have more than one output? No. Does 2 have more than one output? No. Does 7 have more than one output? No. Do you guys see that? 1 only goes to 7. 4 only goes to 9. 2 only goes to -6. 7 only goes to -6. Now, some of you guys are keying in on these both go to -6, right? But can't 2 people have the same size shoe on their left foot? Oh, shit. That's right. The store is like, sold that one 28 years ago. Sorry, you need a size 47. Oh, shit. See that thing? Sorry. Some weird-ass wand shop. Here, about it. Here. Alright, where was I? Oh. So that's fine. So can you create, what would have to happen in this setup? What would have to happen for it to not be a function? This is a function, check.
It's repeated twice.
Yeah, so I'd have to have like 1, 7, and then 1, who cares?
Yeah.
1, 2. And then who cares what else is there? What's 1 do? It goes to 7. And it freaking goes to 2. This one, person number 1 said they had a size 7 and a size 2. Size 2 shoe, what's that? That's baby. You're freaking me out. You have a shoe in your toe inside the shoe? I don't know what that means, right? Do you guys see? Do you understand? So what am I looking for when it's in this form is, are there any x's that are shown twice? Because that x would go to more than one y. That's what matters. Does it matter that does any of them go to the same thing? No, it doesn't matter. How high is this book off the floor? What would you say? Looks about 3 feet. We'll say 3 feet. little more than that, but we'll say 3. All right, let's wait a second. All right, now how high is it? 3.5 feet. It's the same thing, right? So just because it's not moving doesn't mean it doesn't make physical sense. Yeah, of course. What size shoe do you got? Now what size? Now it's like, of course it's going to be the same damn output. 7 seconds later, it's still, same value. Who cares? Maybe. There's one other way to write this, to be honest. So we got the graph, the visual, the graph of the function. We've got a collection of points that the function uses. And then finally, we've got this format. You're going to see all of these formats. So that's just representing this. They represent the same thing. 1 goes to 7. 1 goes to 7. Do you guys see that? So if it's in this format, what am I looking for to make it not valid?
15.
So this is a function, of course, already we know that. Check. That's a function because 1 only goes to 7. So if 1 went to 2 things, what would it look like? So if 1 went to, like I had here, 1 would go to 7, and 1 would... Oh, shit, that's what you're looking for. You're looking for something from the domain having 2 arrows coming out. It means it's going to 2 different things. That one person had 2 different answers for what size shoe they got on. It's like, what the hell? I'm just trying to show you how all of these relate to that same definition. For every x, there could be only one y, but they're going to give it to me in several different formats. But it's the same definition for each. Yes, ma'am?
But if it didn't have, not going to always have the arrows, would it be like 1 and 7 and then 1 and 9?
Oh, that would be really evil.
But how would you know that 1 had 2 functions if there was no arrow?
There has to be arrows. If there's no arrow, that means nothing goes to anything. So if there's no arrow there, then it's like, why did they list that if the function doesn't use it?
How would you know if it was not a function?
Oh, here.
Yeah, how would
Then you're looking to see if any x's are repeated.
That's what I was saying. If it was like.
But look here, what's this? 1, 7, 1, 2. How did I represent that here? 1, 7, 1, 2.
I didn't see that.
Cool. I like it. Okay. So let's get deeper into domain and range, and then we'll head out. This last little piece we'll do today. Let's see what you guys think about this. I was going to use the book, but maybe not. Apparently, it looks like I'm not going to. So, the question here would be, now they're negatives. The question here would be, what are the domain and the range for this? Is this a function, first off?
Yes.
Yes, because it passes the volt. Now, this is where people start to have some trouble, because it's, training your brain to look at this the right way. The domain, again, remind me, domain is a collection of all x values, right? Let me stop there for a second. So the domain is a collection of all x values that the function uses. For example, does the function use the x value of 2?
No.
No, it doesn't use it because there's no output for it. I like it. So that's not a valid question for this function. So it's really saying what pieces of this are valid questions. So what's the first x value that has an output?
-3.
-3. So one way I teach this is, imagine a little dude walking on the x-axis. What's the first time he sees the function at -3? What's the last time he sees the function? At 1. So the domain would be, oh shit, interval notation. -3 up to 1. No.
Just one.
What's the last x value that I use? The biggest x value is 1.
What about -1? That's
What about it?
I mean,
That's the y, negative 1.
sorry, -1. The other one.
It's on.
Oh, this is, it's still the y. I'm not sure what's
No,
happening.
you have the line on the -1 kind of touches the point. You don't have a
That's
point
the
there.
X line.
Oh, I don't care. There's points. I was about to say. Some people tell me the domain is -3, -2, 0, and 1. That's what they tell me the domain is. But it's connected. Is this point a point on the graph? I'm not going to go crazy and try to put a point. There's a point. There's a point. There's a point. There's a point. And there's a. Oh my God, Jeff! Just draw the damn line, dude. So there are some anchor points here. Sure, there are anchor points, so I can graph it. But every freaking point I go through is a point. So does this x value get used? Yes, because it goes right there. There, see? So if the graph they gave you was just points like that, then the domain would be that, comma, that, comma, that, comma, that. I mean, now they're not connected, so none of the in-between points get used.
Because the line is just a bunch of different points.
Connected quickly, instead of making all these little dots.
Together, which make it easier.
So we just make it a continuous line. Kick-ass.
So do we doctrine arrange the same way?
Beautiful. So the range, looking at the y values, which is the lowest, what's the first place the little dude?
-3.
-3?
2.
Good. +2. You don't stop here. The highest output, 2. So -3 to 2. So this is a collection of all the x values that goes somewhere, and this is a collection of all the outputs that those x values hit. All right, let me ask you a freaky question. Can't quite ask that yet. Shit. Crap. Have you guys seen this notation before?
Function of X.
F of x.
That's
I like
the y equals mx plus b.
Exactly, yeah. So anything. If I have y equals x squared. So one reason we use this notation is, what if x equals 2? What's y then?
4.
4. But I've kind of lost information about what's going on. So it's better to use this notation, f of x. It takes the place of y. F of x. Why do I use f? Because we're talking about functions. But then I can use c of x if it's a cost function. P of x if it's a profit function. N of x if it's a number of something. Whatever. So the letter I use can represent physically what the hell's going on. H of x if it's a height. So forth. So now if I said f of x is x squared, and I said, what is f of 2? You just plug a 2.
Where it becomes the X.
Yeah. So f of 2 would be
4.
So, what is this then? What's 2, 4? That is, well, this is neat. When x is 2, y is 4. So that 2, 4 is a point that this function goes through. So this notation is better for a couple reasons. I can see the point that the function goes through all at once. I don't have to remember what I plugged in. I can just see it. Secondly, I can use different letters here to represent different things. If I have just a bunch of y's, I'm like, which y? Shit. But if I got like a function that represents the number of watermelons I eat, I look for the w equation, right? So we'll do more. But real quick, just look at the last little question I want to ask you since I have this up here. Can anybody tell me what f of -2 is? I didn't even tell you what the function was, did I? I don't care. The answer is right up there. Somebody already figured it out. Yeah, at -2, what's the output? That's what that's asking. What's the output for an input at -2? What was the output? 2. You don't have to do the work. Somebody already did the work. So this plugging in work shit here, somebody did it because they graphed the damn thing. So when they plugged -2 in, they must have gotten a 2 out, and that's why they put a point there. That question freaks people out. Real easy. Hello. All right, that's plenty. Those last couple things will obviously go in a little deeper next time. Cool. Anybody not get their quiz back?
No, that's
What you said.
Just corrections like
Well, 100. You can only get above 100 with bonus on the test. Yeah. But you never know. That 1 point might come in handy. Thank you.
It's a long day too.